Welcome to P4. Today we're looking at solving geometric problems in 2 dimensions, unit 7.5. So what we're going to do today is bring what we've learned so far and add into it a bit more about using ratios and a bit about comparing vectors. Okay, so in terms of ratios, if I have a line, say the vector A, or the line AB, or the vector here AB, and if I put a point on that line, say point P, and say that it's in the ratio of 3 to 1, then when I'm looking at AP is going to be 3/4 of AB, because you can see that it's 3 to 1, so total of 4 parts is split into, so 3/4 is AP and PB would be 1/4, so PB would be 1/4 of AB, obviously going in that same direction, so AB, AP picking the same direction. If I looked again and say this time I split it up into 2 parts and 3 parts, so the ratio of 2 to 3, then AP in this case would be 2/5 of AB, because this total line is split up into 5 parts in total, so 2/5 of it will be AP and 3/5 PB. So again, like PB would be 3/5 of AB. And this is quite important, and obviously if you went the other way around, like BP would be minus 3/5 of AB, or 3/5 of BA. Okay, so just being careful with the directions and things that you've already dealt with. But yeah, just splitting up from ratios, converting your ratios into fractions and using those fractions. So let's look at the example now. So here we have the points A, B, and they have position vectors little a and little b. It's worth noting that often with position vectors, which is from the origin, so the vector OA is the same as coordinate A, but often that position vector OA is called little a. Position vector OB is called little b. If you had a position vector OC, it's often called little c. So that's just the way these are often set out. Now let's get back into the question. So P divides AB in the ratio of 1 to 3. Now when you look at this, it's obvious from the diagram in this case, but if you didn't have a diagram, you just need to think about the order. So we're doing from A to B and it's 1 to 3. So from the direction of A going towards B is 1 to 3. So if you didn't have a diagram and you just set it out, that's how you would do it. Now the total number of parts is 4. So you know it's going to be 1/4 and 3/4. So now we have to find the position vector of P. So we need to find OP. So we're actually looking for OP, and to get that we can go essentially OA and then AP. Now as it stands, I don't know AP. So I'm just going to go off to the side here. And AP is going to be a fraction of AB. It's going to be 1/4 of AB. And again, AB I don't know, do I? I'll pop this down here. So AB is going to be A to O plus O to B. So A to O is minus A and OB is B, so we got B minus A. So going back up to my AP, we got 1/4 B minus A, which now we can substitute into my original. So OA is A plus 1/4 B minus A. So it's A plus 1/4 B minus 1/4 A. So that gives me 3/4 A plus 1/4 B. So I can leave it like that, or I can take a quarter outside, and that would be 3A plus B inside. So there's a few ways in which you can do that. Obviously, you can leave it in this form or this form. I would suggest that in a question with vectors where there's going to be additional parts to it, usually the factorizing part will help come into play a little bit later on when you're often looking at parallel vectors or collinear vectors, things like that. If you haven't heard of a collinear vector before, it's essentially when you've got or collinear points, essentially. It's like if you've got 3 points and it's whether they are in line with each other, so you have a vector AB and a vector AC and you're just kind of showing it's the same. But we'll get on to questions like that later on in this series of videos. So, second example, a little bit harder, but not too much. So you can see here that M is the midpoint of OA, and Q divides BC in the ratio of 1 to 3. Now, for part A, we're going to first need to know what vector AC is. So vector AC is A to O plus O to C. Now OA is A, so AO is negative A and OC is C. You'll start to see a bit of a pattern with these in terms of going from one vector to the other. It's a negative and a positive, and that kind of comes up quite a lot. Now let's also work out a few more vectors that we might very well need here. So vector A B, for example, and vector BC. Now AB first, if it's a square, so AB is going to be equal to OC, which is C, and that's quite important, and BC is going to be equal to AO, which would be a negative A, if I'm thinking of that direction. Okay, so those are quite, all going to be quite important as we move forward. Now we want to find P, so it's a little bit awkward because we don't obviously know the ratio at this point for part A. I know it gives it to us in part B when we're trying to find it, but at this point we don't know. So let's start by finding MQ. Now we know M is half of OA, so that's going to be useful in a minute, but let's go MA plus AB plus BQ. Okay, so I'm purposely going round in the ones that I know. So MA is going to be half of OA. AB is going to be the same as OC, which is C, and BQ is going to be 1/4 of BC. So we got a half A plus C, and BC was minus A, so we got minus 1/4 A. So that gives me 1/4 A plus C. Now P lies on both MQ and AC. So if I think of the ways I can get from O to P now using the information I got, I can go O to M, M to P. So that is OM plus MP. And then the other way is OA AP. So OA plus AP. Now OM is a half A, and MP is some fraction of MQ. So it's a half A plus lambda, a quarter A plus C. And then looking in the other way, OA we know is as A, and AP is again some fraction, which we don't know, of AC. So A plus the fraction, and AC was C minus A. Now, these two are obviously equal. OP equals OP, so half A plus lambda, a quarter A plus C equals A plus mu C minus A. And what I need to do with this is separate out my A's and my C's, and the same with this one. So we've got, in terms of A, let's put it like this, we've got half A, and we've got lambda over 4 quarter, a quarter lambda A, plus lambda C. And then on this side we've got, if we look at the A, we've got 1 minus mu plus mu C. So if I expand this bracket, I get mu minus mu A and a single A, which is factorized, and I get mu C. And the same with this one, expand the bracket and then factorize. Now comparing my A's and my C's, I'll do that just in red, so it's easy to see. So we get lambda a quarter equals 1 minus mu, and my second comparison is comparing the C's, and I've got lambda equals mu. So they're essentially the same size, so it doesn't matter which one I use. So substitute, one equation into the other one. I would get a half plus lambda over 4 equals 1 minus lambda, and then it's a matter of kind of factorizing. So we've got 5 lambda over 4 equals a half. So times in by 4, dividing by 5, gives me that lambda is 2/5. And then I'm going to substitute that into this equation here. And I'll finish this off in green. So we've got OP is, and it's half A plus 2/5 times a quarter A plus C. So that means, sorry, before I go on, I missed out that A there. So we get 3/5 A plus 2/5 C. And equally, I could have found out what mu is and substituted it into this equation here. Now, for part B, we need to show that P divides AC in the ratio of 2 to 3. So what we want to first look at is finding the vector AP, and then finding the vector PC. So AP, taking a route that I know, I'm going to go A to O, and then add O to P, which is something that we have just found. And to find PC, I'm going to go from P to O, and then O to C. So again, I'm using essentially what I've just found, but the P to O, so the negative version. A to O is negative A plus OP, which is 3/5 A plus 2/5 C. So that is going to give me 2/5 C minus 2/5 A. So taking that outside, I get 2/5 C minus A. Now this is exactly what I'd expect to be seeing. C minus A is what AC is. So it's the same vector, but 2/5 of it, so 2/5 of the way along, falls exactly within my ratio of 2 to 3. For the second one, I'd expect to get 3/5 C minus A out. And let's check it. So P to O, and this is the opposite direction, so minus 3/5 A plus 2/5 C. And OC is C. So we've got 1C. Let's get rid of the brackets first, actually, before I end up making a silly mistake. So 1 take away 2/5 is 3/5 C minus 3/5 A. Factorize out my 3/5 and I get C minus A. So therefore the vector AP in the ratio with PC is in the ratios 2 to 3 as required. Okay, very straightforward, hopefully. But you can see how now the factorizing is what makes sense. So I don't tend to leave my answers like this, as often in other parts of the question you need it in its factorized form to be able to compare nicely. Now, just before I pop the questions and then answers up as usual, big welcome to some of my new subscribers. And while we're talking about subscribers, there's still just over half of you who are yet to subscribe. And please do subscribe if you are finding these videos useful. It does help me out, or may certainly help someone else out find these videos and help them with their A-levels as well. Thank you. prove that C, M and N are collinear, we've got to prove that they basically lie on the same line. Now we can do that in one of a couple of ways. We can find the vector Cm and then the vector Mn and show that they are essentially the same, like parallel, okay, but they'd be parallel but also joined by the same point, therefore they have to be on the same line. Alternatively, we could find Cm and Cn. Again, these would show parallel, but obviously a different multiple, like the others. And again, it's the same point here. So C to M, C to N. If they're parallel and they start in the same place, they have to be on the same line. Okay, so that's the kind of thing that we need to do. We need to essentially show that two vectors are parallel, but we have to have at least one common point there. So in this case we have the M as the common point, this one we have the C as the common point. Equally we could do it with the N as the common point as well. Okay, but that doesn't always make as much sense. It's usually far easier to go to the middle and to the end, or to the middle and from the middle across. I think most times starting in one point like that is usually the better way to go, but it does depend on what you've already found previously in the question. Now in this case we can see that OM and ON there, we've already found those, haven't we? So starting at C, we can go C to O to M and C to O to N. And what that'll do is that'll give me C to M and then C to N. And what I'll be looking for is to show that these two are both parallel, and since they start from the same point, they must be on the same line. So you can see here that both of these vectors are parallel. So Cm and Cn, the vectors Cm and the vector Cn are parallel. However, we know that we've got a common point, which is C. Therefore, C, M and N are collinear. And that's it. So I did think, sorry I'm putting it in here, I did mention it during the example about collinear, which is why I thought let's throw a question in anyway. Hope that was okay, guys. Okay, in these type of question, we're just going to be comparing the coefficients of each part of the vector. So in this case, the coefficients of P and the coefficients of Q. So looking at the first one, it's nice and easy. A equals 5 and B equals 3. Now, when I'm looking at the second one, I can see that they're going to equal 0. So if I look at the P's, I've got a 2 there plus B, and that must equal 0. So B must be minus 2. And I've got AQ minus 4Q, and that's going to be 0. So A equals 4. And that's all I'm doing. Okay? Now, in this question where it says that OD produced meets AB at E, what that's basically saying is that we've got to extend OD until it hits that AB. So that's where it hits AB at E. And then what we can think about is that OE and OD are collinear. They're parallel and they're collinear. So if I think about D first, I've got this as a quarter A plus 2B. And OE, we know is A plus K, B minus KA. So that will give me 1 minus KA plus KB, just splitting it up in terms of A and B. Now for OD, it's going to be a multiple of this. So if we multiply by lambda, so lambda over 4A plus 2B is going to be equal to 1 minus KA plus KB. Hopefully that makes sense. What we've done is we've taken OD, we've multiplied it by an unknown number to make it the same length as OE. And then we've written out what OE is. Now what we want to do is compare our A's and compare our B's. So I'll just expand this to make it more obvious. So we've got a quarter A plus a half lambda B. Sorry, don't forget that lambda. 1 minus KA plus KB. So what that means is that a quarter lambda is equal to 1 minus K, and a half lambda is equal to K. Now, what I can do is I can substitute equation 2 into equation 1. So doing that, I get lambda over 4 equals 1 minus lambda over 2. So it's going to give me, I'm going to multiply through by 4 here just to make it a little bit easier. So we get 3 lambda equals 4, or lambda is 4 over 3. Now, knowing what lambda is, we can quickly work out what k is. That would mean that k is, so we've got 4 thirds divided by 2, so it's going to be 4 over 6, or 2 thirds. And we can use either of these answers then to find out OE. As if I look up here, this vector here and this vector are both OE, because this is the extension of OD and this is the OE from earlier. So either value I can use to get my OE, but vector OE is going to be, I'm going to use the K, so 1 minus 2 thirds is 1 third A plus 2 thirds B. Okay, and I get exactly the same answer if I use the lambda. Now for the final part, part D, we need to show the ratio of AE and the ratio to EB. So I could think of, AE as being that vector A to O plus O to E. As we've already worked that out, haven't we? OE we said was 1 third A plus 2 thirds B, wasn't it? So A to O is negative A plus 1 third A plus 2 thirds B. So if I think about this, we got 2 thirds B minus 2 thirds A, which I'll take the thirds outside, there's 2 thirds B minus A. Now if I look at EB, I could go E to O, as again we've got OE, and then plus O to B. So E to O is minus OE, so minus 1 third A plus 2 thirds B, plus, and then OB is just B. So we've ended up with b minus 2/3 b minus 1/3 a. So that's 1/3 b minus 1/3 a. So 1/3 b minus a. So now we can see that these are parallel and they are in the ratio of 2 to 1 because it's 2/3 and 1/3. So we can therefore say that AE is in the ratio with EB from 2 to 3. Okay, nice, hopefully straightforward, and hopefully you were able to follow that okay. Well, I won't say hopefully you enjoyed the video. I feel like it might be a long one today, but hopefully that you've learned quite a bit about these vectors, and I've tried to put some more difficult ones in than you would see perhaps at this point in your studies. Don't forget to subscribe, give us a thumbs up, and if you've got any questions, stick them in the comments. See you next time.